In this screencast, I want to introduce you to some work that I've been doing in LiveCode recently. I set out to take an application that I've been maintaining in LiveCode for quite some time and converting it into a format that I could store in a Git repository very easily. I wanted to be able to see all the script changes that I made to the application. As I would add new features, I wanted to know exactly what code changes had been made, and so I wanted to take advantage of the workflow that Git offers you in that regard when I was working on my LiveCode application. So with the addition of script-only stacks that LiveCode has added, and the ability to use script-only stacks as behaviors for controls in a LiveCode stack, I set out to create a new framework and a new workflow that would facilitate that. Now, I will say that stack files themselves are still, in my workflow, stack files are still binary stacks, so any UI changes you make can't really be stored in a very granular fashion in Git. You're changing the whole thing, but I find that once I've designed the initial application with the UI aspects of the application, a lot of the changes that I'm making are code related, and I get a lot of benefit out of the workflow I've come up with. So in order to achieve my goal, I created a new framework that is called the Levure Framework, which is one that I put together that is all the configuration is done with YAML files, and then it kind of has a design that encourages you to put all of your code into script-only stacks. So what you're looking at here is my ScreenSteps application that I've converted over to this new framework. It was previously in the GLX application framework. And this is the main configuration file. You can see it's a YAML file. You can go through and configure all the different components that are involved in the application, what should be encrypted, what shouldn't be encrypted. There's this concept of helpers that will a helper is really, it's a folder that's a collection of stacks, extensions, or externals that will be loaded into your application environment and provide kind of a standard functionality. The framework comes with some of those. I can define file extensions that the app supports, and what files should be copied in and distributed with the app when I do a build and things like that. And over here you see in LiveCode, this is the main application stack that will load everything else into the environment. So I click this load button, and then everything gets loaded up into memory. Now, what I've been using Sublime Text 3 recently. I worked with another fellow to write a language module for it. I have a linter for it so that I can actually have my code will be checked for errors as I write it, and so it's just like being in the IDE, but better. I mean, the Sublime Text is a dedicated text editor and has a lot of really cool features, and I'll show you some of those right now. But what I set up is in the LiveCode language package, every time you save a file, it'll actually notify an IP address on a certain port that you saved a stack with a certain name and file name. And so my Levure application has a little plugin that loads up. So when this app loaded up into the IDE, it has a server running that is looking for, it's listening for requests from the Sublime Text 3 plugin. And so I can actually work in Sublime Text 3 on my code, and any changes I make will instantly be applied within the IDE, so that I'm still running live and testing, but I'm using my preferred text editor. Let's take a look at how these stacks and script-only stacks are organized in the Levure application, and how you'd use Sublime Text to perform some edits and navigate around your code. I actually find Sublime Text to be even more powerful than the LiveCode IDE itself, as far as looking up handlers and now and kind of following your code paths. It's got some really powerful features in there. So in the Levure framework, it encourages you to break out all of your stacks into individual stack files, and so you don't really have any substacks. So each stack is its own stack file. So here you can see I have an about screen, an editor, and some different dialogues. If you look at the about screen, you'll see that there's the about stack, which that has the UI. You can see that's binary. And then if I open up behaviors, I have a card script and then a field script. And you'll notice right away that as I open up these scripts, you'll see these red dots appear and some text gets highlighted. And that just means that the linter found an error in the code. Now I have explicit vars turned on so that I'm going to get errors if I haven't defined any script locals. And so you can see that right down here. Can't create a variable with that name. And so I can, that allows me as I go through my code, after I moved all this code out of LiveCode and into script-only stacks, as I go through and edit them the next time, I'll go through and fix the explicit vars errors. And so I do that, I save, and now it looks correct. Same thing for this card script. I can go in, and I've actually found a number of errors in my code as I've gone through and done this. I found errors that I wasn't aware of, and so that was kind of a handy way. And you can kind of cycle through the errors and see what needs to be done, what needs to be changed. And so that way, I'm not having any. As I'm coding in Sublime Text 3, I still have the benefit of the syntax, of catching errors. So if I code something that doesn't compile, then this linter will let me know, and I'll get an error. And also, let's say that if I was to do something which is bad, and I tried to save it, see here, LiveCode got notified that I just saved that file, and it says I wasn't able to set that script, and so it won't set it. Now if I go through and fix it, then LiveCode updates without any problems, and I'm good to go. Now in Sublime Text, I can right-click on anything that is defined as a handler, get props, set props, commands, functions, all that stuff, and I can go to definition. It'll take me right to it. Here it was in the same file. This particular file is somewhere else, so it'll load up it'll find the script, the function or command in my code base, take me right to it. I can also search for anything. So I might go to initialize application, and it'll show me all the places where that shows up, and I can open it up, and and Sublime Text will take me right to that handler. Same sort of thing. I can search for any files I might need. Maybe I want to open up my configuration file. I can jump right to that, and it's all very quick and easy because Sublime Text is indexing everything within this project that I have open. So as you can see, I've moved all of my code into these script-only stacks. All of my stacks, they all are stored in independent folders. They have these script-only stacks that are set as behaviors. The behaviors are assigned to, these behaviors are assigned to the stack files of these binary stacks. And so if I load like this ask for preset name stack into LiveCode, the engine will go through and find all the behaviors because they're assigned to the stack files property. Any behaviors I store in separate folders, and the framework will load those up for me. I can also do libraries. Those will get loaded up and put in the message path. There's front scripts and back scripts that you can define as well if you want to do that. And then you have kind of these helpers, which actually I have most of my helpers are stored under here. And so I have one for like hotkeys and an OAuth library, and all the externals that get loaded, are done through a helper, and they're just all stored in this folder. So that's a nice way to package up logic. Default prefs that my application uses are all stored in a YAML file. So what I can do now is, here's a source tree if you're looking at my app on source tree. And the nice thing is I can create different branches. So when I go to create a feature now, I can create a new branch. So I was fixing how some image capture works in our application. So I created a new branch, and I started making some changes to the code. And those changes don't affect my main application. At any time I can switch between this new feature I'm working on and what's my master branch, and my app will kind of change state. So let's say that I'm working on a feature, so I'm going to go through and implement TSNet soon. So for example, I would go and I'd create a new branch, and I'd call it TKD TSNet. And now I can go through, and let's say that I want to change. So all my logic for downloading files is in this data controller file, and within here, I'm going to have I'm going to do all my loading, and actually it's going to be in the cloud file. Let's see, cloud controller. Let's do this. in my cloud controller stack. And so I have a get URL call. I have some other calls, and if I want to make those, if I want to shift those over to TSNet, which has it would be asynchronous over, and it's going to be on a different thread, so I'm going to get better performance. So my app might download a ton of images. So I'm going to go through on this branch in Git, and I'm going to make all the changes to TSNet, and I'm going to be able to test that and make sure that it works really, really well. Now, at the same time, if I have another feature, like maybe I need to implement this image capture template feature in a new release that I'm putting out, but I'm not done with the TSNet feature yet. Well, I can switch back over to this image capture branch, polish off that feature, merge that into master, and release that to my customers while still keeping all the changes that are TSNet related on the separate branch until they're fully done and tested. And so it really gives me a lot, I have a lot more control and a lot more flexibility over how I add features and how I work on features that might take a long time to do. And I'm going to have an audit history of everything I did, because every time I make a commit in here in Git, it's going to tell me, I can specify what changes I made, I can see what changes were made, and as far as me being able to audit my own code and see where I may have broken something in the past, this is really great. And it also is great if I need to bring another programmer in on the project. I can see exactly what they're doing and see exactly what they're changing. And if they ever make a change, if I have them add a feature, I can see exactly what they did and verify all the changes before I then pull those code changes into my project. So that's it for this introduction to this this work I've been doing on LiveCode recently. I have been working with this workflow for a few months now. I really like it. I like the flexibility. I really like being able to work in Sublime Text. I found it to be a very powerful editor, and I'm able to work a lot more quickly when I'm coding. I admit there's still the issue of how you're doing source control for stack files for the UI in the application. I'm hoping at some point that we can, the LiveCode team will be able to put together a format, like a single file format, that allows us to save our stack as a single file that can go into version control. But even still, with that issue, it's because most of the changes I'm making are code related and logic related. I get a lot of value out of this design.